Hello students, welcome to Engineers Academy. Do subscribe Engineers Academy. That will help to promote my channel. Now we are going to solve this problem which says that determine the angular velocity of links AB and BC when theta equals to 30 degrees. So when this theta is equal to 30 degrees, we are required to find the angular velocity of link AB and the angular velocity of link BC. So let's say that this these two red lines represents link AB and BC, and red represents the initial state. So when this point C goes up, since here the block C has a velocity of 6 feet per second in the upward direction, so if this block C moves up, what will happen is that this point B will move towards the left. So this means that this link AB will have the angular velocity in this direction, that is in the counterclockwise direction. And similarly, this point C moves in the upward direction and this point B moves in the downward direction. So link BC is in counterclockwise direction rotation as well. So this means that the angular velocity of link BC is counterclockwise, that is omega BC. And similarly, link AB, the angular velocity of link AB is also counterclockwise. Similarly, as we can see that this point B is moving relative to this point A, so this point B will move in a circular path with the radius of this AB, and that velocity will be tangent to that circular path. So, or we can say that that velocity will be perpendicular to this link AB. So that means that this point B will be moving with the velocity VB in this direction perpendicular to link AB. So we can show that the velocity of point B will be in the horizontal direction, making 90-degree with link AB. And the magnitude of this velocity will be equal to the radius times the omega of link AB, since this will VB velocity is only due to that angular velocity of link AB. So we can say that the magnitude of VB will be that radius of the circle about which this point B is moving multiplied by this omega. So this will be 1, since this is 1 feet times omega AB, so that will be omega AB. So VB magnitude is actually omega AB. And similarly, we will have that same VB here as well at point B, since this represent link BC. So we will have this same VB velocity here. So this is that VB. And the velocity of point C is in the upward direction. This is given that this point C is moving in the upward direction. So we will represent that velocity here. So this point C is moving up with a velocity of 6 feet per second. And now let's write that relative velocity equation for point B. Let's say that VB is equal to the velocity of C plus the velocity of B relative to C. So now we need to look for the direction of this velocity, the velocity of B relative to C. So this velocity is always due to the angular velocity of this particular link. So this velocity of B relative to C will be due to the angular motion of this link BC, or we can say that this velocity is always due to this omega BC. So since is from here we can see that this link B moves toward this side. So the angular velocity is like this in the counterclockwise direction. So this velocity of B relative to C is due to this omega BC. So this velocity will be tangent to this BC. So if we are talking about the velocity of B relative to C, so this point B is moving toward like this. So this velocity will be tangent. So the direction of the velocity of B relative to C will be in this direction, and this will be perpendicular to that BC link. Since this velocity is due to this omega BC, and we consider for this velocity is if this point B is rotating about that point C in a circular path. So then if this point B is rotating in a circular path relative to this point C, then this velocity will be tangent to that circular path. So now let me show that velocity of B relative to C here. So this velocity of B relative to C is going to be perpendicular with that link BC. So this is velocity of B relative to C. Now, just like the velocity of B, since this velocity of B is only due to the angular velocity of omega AB, so its magnitude was r times omega AB. Similarly, this velocity of B relative to C is only due to omega BC, so we can say that the magnitude of this velocity will be equal to the 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 length of this BC times this omega BC, since this length of BC will represent the radius of that circular path about which this point B is moving relative to that point C. So we can say that the magnitude of velocity of B relative to C is equal to RBC, or we can say that the length of this BC, which is 3 feet. So we will write that this is 3 times omega BC. So now we know the direction of VB, we know the magnitude in terms of omega AB. Similarly, we know VC. VC is given directly. We know the direction of velocity of B relative to C and its magnitude in terms of omega BC. And we will apply this equation, and we will apply it in the horizontal and vertical direction. So we will apply it in components form, or we can say that we will find the solution by using the scalar method. So we are going to apply this equation in the horizontal direction. Towards the right is our positive direction. Let's define our coordinate system. So towards the right will be our positive x, and in the upward direction is our positive y. So we will apply this equation in the horizontal direction. We will apply this equation in the horizontal direction. So we will write that this will be vbx, the component of the velocity of B in x, vcx plus velocity of B relative to C in x. So now as we can see that this VB is only acting in the horizontal direction, that is in the negative x. This is our positive x, VB is acting in the negative x, and its magnitude is omega AB. So we can write that this is VB in the negative x. So we will write minus omega AB, since this is in the negative direction. This is our positive direction. So the magnitude of VBX is omega AB, and it is in the negative x. So minus omega AB is equal to VC x. So since VC is only acting in the y direction, so its x component is 0. So we can say that this is 0. So this is 0 plus, now this is the velocity of B relative to C. It is perpendicular to that BC, and here we have angle given which is 30. Here we are given that this angle is 30. So let's represent that angle here. So this angle is 30. Now as we can see that this BC is perpendicular to this BC, and if we draw a vertical line here, so this vertical line is perpendicular to this blue line. So if the angle between this line and this line is 30 degree, then the angle between this and vertical line is also 30 degree. So this means that this velocity of B relative to C is making 30 degree with the vertical. So we can write that this angle is 30 degree. So this velocity of B relative to C is making 30 degrees. So now we can resolve this velocity of B relative to C into its components. So we will have one component in this direction, and we will have one component in this direction. This one will be the cos component, this one will be the sine component. So now as we can see that this velocity has one component in the negative x, and this is the sine component. So we will write that that component is in the negative direction. So here we will write minus. In this equation we will write minus, and that velocity of B relative to C sine of 30 degrees. This horizontal component is the sine component. This is the cos, so this is the sine. And now we know that this velocity of B relative to C is equal to this 3 omega BC. So let me write that this is 3 omega BC. So now this is 0 plus this, so we can remove this 0. And if we divide both sides of equation by let's say minus will cancel out, so we will be left with omega AB equals to this. Now this is one equation and we have two unknowns. So let's say this is equation number 1. Now we will apply this same equation but in the vertical direction. So we will apply this in the vertical direction. So we will have VB y equals to VC y plus velocity of B relative to C in the y direction. So now we will look for the vertical components. So now since VB is only in the horizontal direction, so its vertical component is 0. So this is 0. So we will write 0. And VC is only acting in the vertical direction. So this is 6 feet and this is in the positive direction. So you will write plus 6. And this velocity has one component in the downward direction, and that is the cos component, and that is in the negative direction. So we will write minus, and that will be velocity of B relative to C cos of 30. And again this magnitude is 3 times omega BC. This is 3 times omega BC. So we will replace this with 3 times omega BC. Now from this equation we can write that minus 3 omega BC cos of 30 is equal to, we need to bring this term to the other side. So this will become plus, right? So this will become plus, and we will have plus 6. And similarly, you want to find omega BC. So this will be 6 divided by 3 cos of 30 degree. So 6 divided by 3 cos of 60, 3 cos of 30. So this is 2.31. So omega BC is 2.31 radian per second. And omega BC is in the counterclockwise direction. So 2.31 radian per second in the counterclockwise direction. Similarly, if we put this value in this equation, we will be able to find omega AB. So omega AB is equal to 3 times 2.31 sine of 30. So 3 times 2.31 sine of 30, this gives us 3.45, 3.47, let's say, radian per second. And again, this is in the counterclockwise direction. So now this is one way of solving this problem. And now we are going to apply the vector method. So let's erase all these. So now we will apply the vector method. So by vector method, we will apply this equation. So for that method, we need to write this VC as a Cartesian vector and this velocity of B relative to C as a Cartesian vector. And similarly, we can write this equation in terms of omega BC. This will be equal to VB, and this is equal to VC plus this is omega BC cross product with the position vector of B relative to C. So now we need to write this velocity of B, velocity of C, and all of these in vector notation, right? So velocity of B, so since VB is only acting in the horizontal direction, its magnitude is omega AB. So we will write that omega AB in the negative I, and its J component is 0 since it is only acting in the horizontal direction. So this is VB in terms of its I and J components. This is equal to VC. Now VC is only acting in the upward direction, that is in the J direction. So its I component is 0. So we will write that this is 0 I plus 6J, and then plus, now omega BC is in the counterclockwise direction. So if you guys curl your right hand fingers in the direction of omega BC in the counterclockwise direction, so the thumb will point out of the screen. So out of the screen is our positive Z direction, right? So if this is the positive X, this is positive Y. So out of the screen is the positive Z direction, and that positive Z direction can be represented by a circle and dot. So the z axis is out of the screen. So if you guys curl your right hand fingers in this direction, so the thumb will point out of the screen. So this means that omega bc is in the positive k direction. So we can write that this will be omega bc in the positive k direction, and cross product with position vector of b relative to c. So we need to draw a position vector from c to b. So let's draw that. So that we will have that position vector from C to B, or we can say that this pink line represents the position vector of B relative to C. So now we need to write this in terms of its components. So this BC is making 30° with the horizontal here. So this position vector from C to B will have two components. It will have one component in this direction, and it will have one component in this direction. So this component will be the cos component, and this one will be the sine component. So let me draw that BC vector here. So it is making 30°. So it will have one component in this direction, and it will have one component in this direction. So this is 30°. So this is RBC cos of 30, and RBC, this length of BC is 3 feet. So this will be actually 3 cos of 30. So we will write that this is 3 cos of 30, and this is 3 sine of 30. So now we can write that RB of C is this horizontal component is in the negative x. So this is 3 cos of 30 in the negative I, and 3 sine of 30 is in the positive j. So we will write plus 3 sine of 30 in the positive j. So this is the Cartesian vector representation of that RB relative to C. So now let's write it here. Minus 3 cos of 30i plus 3 sine of 30j. So this is the RB relative to C. So now we can write this equation is minus omega ABI plus 0j equals to 0i plus 6j. And now we need to take the cross product of this with this and this. So omega BC into this will be minus 3 omega BC, and k into I is plus j. So k into I is plus j. So we will write that plus minus 3 omega BC cos of 30 into plus j, and similarly this into this. So this will be 3 omega BC sine of 30, and k cross j is minus I. So we will write that this is minus 3 omega BC sine of 30 I. So now we can compare both sides of equation. We will compare I component with I and j with j. So here we have 0i and this. So we can write that minus omega AB. From this side, this is minus omega AB. This will be equal to 0 minus this. This is 0 minus 3 omega BC sine of 30. And again, we can remove this 0. Minus will cancel out. So omega AB is equal to 3 omega BC sine of 30. We got this same equation using the other method by just adding the x components. By applying this equation in the horizontal direction, we got the same equation. And similarly, if we now compare the j components, so 0 will be equal to 6 minus this. So we can say that 0 is equal to 6 minus 3 omega BC cos of 30, and from this we can say that 3 omega BC cos of 30 is equal to 6, and omega BC is equal to 6 divided by 3 cos of 30. So again we will get that same answer, 6 divided by 3 cos of 30. This gives us 2.31 radian per second, and omega BC is in the positive k direction, right? So in the positive k means that it is in the counterclockwise direction. And similarly, putting this value in this equation will give us omega AB. So we can write that omega AB is equal to 3 into 2.31 sine of 30 degrees. So we can say that omega AB is 3 times 2.31 sine of 30. So this is, we can say that omega AB is equal to 3.47 radian per second. And this is also in the counterclockwise direction. This is in the counterclockwise and this is in the counterclockwise. So this is the solution of this particular problem. I hope this will help you in your learning. Do subscribe Engineers Academy for the solution of such more problems from chapter 16 Hibbeler Dynamics.